All right, so we're going to talk about real number exponents, okay? And we have an exponential function here. And we have exponential functions when your base is greater than 0 and it's not equal to 1, okay, this base b. And your variable is the exponent. All right, let's take a look at example number 1 and work with some real number exponents. Now, remember your laws of exponents apply here. So we want to find, if we have the same base, we have to add the exponents, okay? So we're going to take 2 to the power of 4 minus the square root of 5 plus 1 plus square root of 5. And then you'll notice your square roots of 5, they're going to cancel out, and 4 plus 1 is 5. So that gives us 2 to the 5th, which is 32. So that's our answer for example number 1. Now let's take a look at example number 2. Remember, with your laws of exponents, you're going to be multiplying these exponents. So we have 2 times the square root of 3 times the square root of 3. Now remember, square root of 3 times square root of 3 is 3. So we have 5 to the 2 times 3, which is 5 to the 6, which is 15,625. And that's it. Now let's take a look at example number 3. All right, so here we have division, and we have the same basis, so we're going to subtract the exponents. So we have 3 to the 2 plus square root of 7 minus, and then we're going to put a parenthesis because we want to subtract that whole thing. So 2 minus square root of 7, and then we're going to distribute that. So we have 2 plus the square root of 7, and we're going to distribute our negative. So minus 2 plus the square root of 7. Our 2's cancel. So we have 3 to the 2 square root of 7. And that's it. All right, let's take a look at example 4. We want to solve. Well, right now, we don't have the same base, so we need to manipulate the left side and the right side in order to get the same base. Well, what do they have in common? They have 2 in common. So the 4 can become 2 squared. So you have 2 squared. And remember, that was to the power of 2x. And then the 1/2, remember, can be written as 2 to the negative 1. Because remember, a negative exponent means you flip it, you make the reciprocal. Okay? So then you have to the 1 minus 2x. Okay? So now we have the same base, we can go ahead and multiply our exponents. So we have 2 to the 4x equals 2, and now negative 1 times 1 is negative 1, and negative 1 times negative 2x is positive 2x. And now because we have the same bases, our exponents have to be equivalent. So we can just set that up as an equation, subtract our 2x, and divide by 2. So x equals negative 1/2. And you can check your answer by plugging it back in to see if you get the same thing on both sides. Now let's take a look at example 5. Again, we don't have the same basis, so we need to get the same basis. Well, we can easily get a 5 here on the right-hand side if we change that to 1 over 5 squared, and then we can make it negative squared. So 5 to the negative 2 is the same thing as 1/25. Okay? And then remember that we had this 5 to the 3x, and then your 1/25 was being raised to the power of x minus 1. All right, so now we can multiply these two exponents. So our 5 to the 3x stays the same, and then negative 2 times x is negative 2x, and then negative 2 times negative 1 is positive 2. Now we have the same bases, so we can set the exponents equal to each other. And then add the 2x and divide by 5. So x equals 2/5. And again, you can check that answer by plugging it back in and seeing if you get the same answer.